Barakatuh. Assalamu alaikum warahmatullahi wabarakatuh. So now what we are going to discuss is basically the PLC, Programmable Logic Controller. For your info, let me put it in sliding mode. So, so this is the slide mode. Let me turn on the pointer. Okay, so first we are going to discuss the basic symbols of ladder logic. So these are the two most important symbols that you will be using in PLC programming. By the way, the syntax that we will be using for PLC programming is Allen Bradley PLC from Rockwell Automation. So this is normally open, is called normally open, meaning to say if this is not true, this condition is not true, this normally open remains open, meaning to say it will not carry current. But normally closed means when the situation is off or the condition is false, then this will become normally closed will become open and it will stop carrying current. But if it is false or off condition, it will remain as closed. Normally closed will remain closed and it will carry current. You may have a positive transition seeking contact and negative transition seeking contact. So meaning to say when the transition goes from off to on, then only it will carry current, and vice versa. If it goes from on to off, during that transition only it will carry current. So if I draw it, then it will look like something like this. So for this case, if it goes from off to on stage, during this transition only this thing will be activated. During this time, it will not be activated. However, for normally open type of contact, if it goes from here to here, from off to on, this whole stage, it will be considered closed as long as it remains on. When it goes off, then this will become, when it goes off, this will become open again. So this is how the system works. Now for output, you have general purpose output like this. So when your input is carrying current, then your output will be energized. Let's say, for example, if you have a system like this, ladder logic system like this, let's say is I1, and this is the output O1, output 1, input 1. So when this one is true, meaning to say it will start to carry current from high voltage to low voltage, so carry current, and this will become energized. But if you use a negated coil like this, then when it is not carrying current, then it will be energized. When it is carrying current, it will be de-energized. You may have something called set and reset as well. So if you have something called set contact, so if you press set, meaning to say it will, when it becomes closed, meaning to say the condition becomes true, it will be set. And even if the condition becomes false, it will become open again, but the set will not be reset automatically. You have to have another input condition to reset this contact, the output. So this is how this system works, basic system works in PLC. You have positive transition detecting coil, meaning to say when it goes from, when the rung goes from true to false, only during that time it will be turned on. And you have negative transition sensing coil as well. Retentive memory coil, set retentive memory coil, these are not so common, so you can ignore these things for the time being. Now, in Rockwell Automation, the PLC system mostly looks like an expandable PLC system. So you have a power supply and you have a controller unit, and then you have expandable slots. This is the data back pane where you can slot in the IO module. You can see module slot into the rack. So, and then it will be connected to this power supply as well as a processor. This is the processor unit, CPU unit. So this is let's say for example, initially you may need only one card of IO. When you expand your company, your industry, you may want to expand the IO slot. So then you can buy a new IO card and you can slot in there to expand more IOs. So it is expandable type of PLC system. So in PLC, you have both syncing type input output and sourcing type input output. So if you have an NPN type of system transistor switch, then it is for output. This is for output. So you can see when you activate this output, so the current flows if it is a NPN type, so it goes from positive voltage 24 volt standard to the ground through this activated output, which becomes shortened when this activation signal comes in this base. So this basically acts as a transistor switch. So this is input NPN output switch. So you can, by programming, you can turn on and off each switch, and based on that, you can turn on and on the load. But the main thing is the hardware is connected. This output will be connected to the ground side. If it is a PNP type output, then your output will be connected to the 24 volt side. As you can see, this is PNP. Same goes for the input. Uh, this is a syncing type input. So basically, if this acts as a sensor, maybe a photodetector sensor or such, so it is connected to the ground side if the sensor is NPN type. So 24 volt goes through this to the ground, so the current, the circuit is activated, and this input is sensed inside your control unit. If it is a PNP, then it will be connected to the, as you can see, it will be connected to the 24 volt side. So this is syncing and this is sourcing. Now, this slide shows how you're going to, in Rockwell Automation, Allen Bradley PLC, how are you going to name your inputs. So this is the syntax, I colon the rack or slot number, because I have sent in each slot you can slot in various IO cards. So each card usually will have 0 to 16 or 0 to 15 or 0 to 31, either 16-bit or 32-bit of inputs. You can have more, but this is a typical case. So let's say, for example, if you have something like I colon 1/1, meaning to say it is the first rack and the input number is on the first rack, the card that is associated, the terminal number 1 is the input you are referring to. So this is the example. Similar to input output also, you have rack slash the terminal number. Okay, let's move on. Okay, now we are going to discuss some of the basic type of uh, ladder logic system. So in ladder logic, you will have, it looks like a ladder. So this is the two vertical pole you will have, and inside you will got various horizontal lines like this. So this is called rung, RUNG. You can have multiple rungs. Usually you can have even 10, 15, 20 rungs in a single PLC program, even more than that. So, so this is called rung. And this overall called ladder program. When you finish your program, usually you end with an end statement like this, like this. So this is a NOT gate as you can see, if you have 0, you will have 1 output. You have 1, you will have 0. So you mean to say it is just reversing the output. So it's a NOT gate. So you can have something like a normally closed, like this, normally closed input, which is connected, which is your actual input. So you press this switch. If it is a switch, you press this switch. When you press, it will become open because this thing will become true. When you press the switch, it will become open because you are considering this switch as a normally closed. Now, it doesn't have to be the switch in and itself should be normally closed, but you can program it as a normally closed. That is the beauty of PLC. So you can have a normally open type of switch, but you can program it as a normally closed. So when you don't press the switch, you will see the light is on. But in normal case, if you press the switch, the light should be on. But in this case, because you have programmed it as normally closed, if you press it, the contact will become open, and your physical switch, even if it is pressed, it will be turning off the light. So this is the simple programming technique. You can also program it in a different way. Instead of this, if it is a normally open type of switch, you use it as a normally open type of switch, and then you use an internal contact which is not connected to any outside. B stands for it is internal use. B3 in Allen Bradley stands for internal use. You use it as a B300, is a virtual contact, and it is not connected to any physical system, and you use it in the first run as an output, but in the second run using it as an input. You can see that memory address is same, B300. The bit address is the same. So you use it as a input, but this time you're using it as a normally closed, and then it is actually driving the pilot light. So what happened is you press this switch, so this one will become true. Once this is true, means normally closed will become open, so the light will be turned off. But if you do not press it, it will be false. False means normally closed contact will carry the current, and your pilot light will be turned on. Now, let's move on. So if you want to use an AND gate, it is basically two contact are in series, and you can operate light using two switch should be turned on to make sure to make the light to be turned on. If you use a NAND gate, is basically AND plus a NOT gate. So if you use an AND gate plus a NOT gate, then you will get a NAND gate. So basically you can use two AND gate. You are driving a control relay, internal control relay, and then you use it as a NOT to drive this pilot line. Or you can do it in one single line using OR condition. This is an OR condition when you put the two contact in parallel. So if you press this first switch, so basically if you make it both pressed, so both contact will be uh, normally closed will become open, and your light will not be on. So if you have basically 1 1, then you will have 0. But if you don't press anything, so any one of them will carry the current, and it will be on. If you press one of them, so at least one of the line will carry the current, and it will be on. So this is how the NAND gate works. This is the NOR gate. So this is OR plus and NOT gate. So the solution is this. So you can try to, I will show you how to simulate these things using LOGIX Pro. So you can redo these things, and you can see how this system works following this truth table. So just to show this one, if you do not press any one of them, it will be on. But if you press any one of them, the line will be broken and it will be off. Exclusive OR. This is interesting. So if you want to do exclusive OR, only when OR condition is satisfied, your output should be turned on. So you are basically using same contact in first run as a normally open, but in second and normally closed. Here, the second contact is normally closed, and the second run, it is normally open. Now, if you press the first one, do not press the second one, then this line will carry current and it will be on. If you press the second one, meaning to this one, and do not press the first one, then it second line will carry current and the light will be on. If you press both of them, then you will see if you press this one and this one will become open. Then if you press this one will become open, but this one will close. So you will have some break in the current carrying rung and your light will not be turned on. If you do not press any one of them, also the line is broken, you can see, and light will not be turned on. Okay, now it is a combination of the logic system. So as you can see, you have PBR, PBG, these are some input names, and you are connecting to exclusive OR, NOT, and NAND gate. So you can do it just using the previous examples, and you can develop this logic system using PLC, and this is how the PLC would look like. So this is the PLC system would look like. So what happened here is basically this is the exclusive OR condition. With exclusive OR, you have the NOT as an AND. So that's why they are in series. And that output is PLTR. And this PLTR with the TSW is in NAND condition. This is the NAND logic. And this is the final output PLTW. This is another conditional logic circuit. Uh, let me This is the example of that logic system. You can read it also. So this is basically this is the AND, this is OR, and this is AND. So basically AND going with a NOT as an OR condition, and then you have this another AND condition. Sorry, first and then you have SW as an OR. Output of the OR goes to this TSW not as an AND condition. So this is how the system works. Mm, Okay, so there is nothing for these slides. Now I'm going to show you how to simulate this LOGIX Pro. I think I discard this thing. Okay, so if you go to this website, as you can see, I will share the link later on. You can download this LOGIX Pro and then you can install just normal installation process. Then you can have this LOGIX Pro simulator installed in your system. I think this is for 15 days. It is free, but you can heavily use it. After 15 days, you may have to purchase it. But if you don't purchase, also okay. So if you, I have purchased it, so I have a perpetual license. So if I press this one, so this is how this thing will appear. So this is the rungs, as you can see. Okay. So let's say you want to make a new file, just keep it default. I think you can just press OK, and then you can add. These are the various menu bar. In the menu bar, you will have various types of things. So this is called rung. So if I want to add a new rung, so this is the new rung. It appears a new rung. So I want to add a normally open type of contact. So I bring here a normally open type of contact here. So it comes as a new rung, but I want to bring it here. So I just drag it and put it there. And then I put an I select this one, I put an output. So this is the output. And I have to name it as I have mentioned. So what you can see here, you can go to simulation. It has IO simulator. You click IO simulator. So it will appear like this. So you can see in the first slot, you have I1 and then O2, and second slot is second output and third slot. So you have basically, you can use only first slot I1 and I3. So I put it as I1. So I1 colon 1 slash 00 or 0, meaning to say I am referring to this particular switch, and this is connected to a push button switch. If you go here, you can right click this one. You can see it changes. It is now normally closed push button switch, but the contact is normally open. You can click again. It becomes another type. It's not push button. It is a maintain contact. You click another. It is a normally closed maintain contact. You click another. It is a normally open maintain contact. And you click another. It will become push button again. So now this one I put here O2 or 2 O colon 2 slash 0. So it is connected to an LED. So this rung contains nothing. So I delete this one. Okay. Now let's try to show you some simulation. I saved it as save as test one. Okay. Now let's see what happens. If I want to simulate this, I click this thing. So I press this one, and then it will download to some virtual place. So just click download and then press run. So now if you press this thing, you see what happens. If you press this one, you see the LED is turned on. Once you press, your LED is on. Press, LED is on. Now because it's a push button, so as soon as you press it, it will be on. If you depress, it's like a spring loaded push button. Another name of this type of contact, they call it momentary contact. And if I click right button, it will be changing the contact. So this is a not a push button, this is a maintained contact. It's like a normal switch. If you press, it will remain pressed even if you remove your hand from there. So it will be on. If you unpress, you depress, you do the reverse pressing. Okay, now I bring back to push button. Okay, now I go to program mode, and this one I change to normally closed, change to XIO to XIC, change to XIO, examine if open. XIO means normally closed. It has another name. What it means is XIO is examine if open. XIC means examine if closed. So if I check here XIC, it will become normally open. If I make XIO, it will be normally closed. Now I do the same simulation, see what happens. I press, you see I didn't press it, it is on already because I have programmed it as normally closed, though the switch itself is normally open. Now I press it, so what will happen is it becomes turned off if I press it. If I do not press it, it will become energized. It will cause the bulb to be output to be energized. So this is how the system works. Okay, now I show you another interesting trick. Let's say I use let's say this contact, I make it normally open. Okay, let's say this is a motor I want to turn on, and I want to use push button only to turn on a motor, but I don't want to keep pressing this push button all the time so that so that I can keep my motor running. I just want to push it for a momentary time, and then I want to motor to be self running even if I don't keep pressing the push button, start button. So let's say I name this button. I can click right button and then say edit symbol. So then the name appears. So I put this name, a descriptive name. It's a start button. Start button. Okay. And then I want to make sure that when I press it, it will start causing this motor to run. But even if I don't keep on pressing, the motor should keep on running. So how to achieve these things? So this one, I show you how. I press a parallel path here. So this parallel path, you have to drag it down to this, okay? And then here, what I do is I bring a normally open contact. And this one, I name not a different contact, rather the output itself, O colon 2 slash 0. Okay, and then this one I edit symbol. Name it as motor indicator. Meaning to say it is be turned on to show the motor is running, motor indicator. So you can see they are now same thing. So as soon as I change here, it gets changed here. So now I need to stop the motor as well. So for a stop, I need to add a stop button. So what I have to do is basically create another stop button, I colon 1 slash 1, and I name it as stop. So if I download it, what will happen? Let's see. I press save as test2 latch. This is called latch example. So if I go here, I download, now I press run, what will happen is, so if I press, so you can see it is, even if I don't keep on pressing, still the motor is running. So what happened here is basically once you press it, because this is normally closed, the stop button is normally closed, so it is already carrying current. So once you press it, this rung will start to carry current. Now at the same time, I'm using, once this motor is energized, immediately this parallel rung will also carry the current. So you don't have to keep on pressing because the parallel is taking care of this. This is called latching. So I have latched the motor already. Now, if I want to stop, so what I have to do, if I press this stop button, this normally close will become open and it will cause the motor to be a stop. And if you remove it, it will be again, normally close will become to carry, it will continue carrying current. So this is what we have discussed so far, inshallah. So this is the normal input outputs. We will discuss, okay, let me explain another example. Then we go to program mode. Okay, go take another example. Mm, okay, these examples we will discuss later, inshallah. We have some examples. These examples we will discuss later, inshallah. Farm, parking lot, latch. Yeah, this example. Okay, there is this latch, another latch we want to discuss here, as you can see here. Okay, so this is the latch. You can see the first latch is what I have explained. Okay, start, stop, and motor 1 is causing it to be self-running. But you can have another latch which you use a latch button itself. So this is I11 and I13. So you are running O21, O2. So let's try to do this thing. So you can do here I11, meaning to say you press this, so it will latch this motor. So our motor is start to running. So it is a bit different. So you're using the latch output instead of normal. This is general purpose output. This is latch output. And then to unlatch it, you have to press I13. You can see it is I13 as a stop to. So you press I13, it will be turned off. So this is another way to use the latch. So I hope you have understood this concept. Next class we will discuss something else like timer and counter and so on so forth. Thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.